In this video, we will be talking about Spring. Spring is a framework for the Java platform and it is majorly used for creating enterprise applications. So, by enterprise applications, we mean applications which need to be large and scalable. They need to be robust. They need many functionalities like transaction management and security, and so on. So before Spring, there were many frameworks or APIs which were used for enterprise application development. Struts was one of them, which was very popular. But Spring is a very lightweight framework, and it can also support other frameworks such as Struts, Hibernates, EJBs, JSF, and so on. Also, Spring is very flexible because it provides very good extensions for third-party libraries. It is also very fast. So when you're using Spring, you will notice that the startup of the application and the shutdown of the application is very fast. The application is very reactive, so it does not block. So it is a very responsive application. So there are many advantages of using Spring. The advantages of using Spring are that it is very lightweight. It is lightweight because it uses Java beans. So Java beans are nothing but Java classes which have private data members and public getters and setters. So that is why Spring is said to be a lightweight framework. Spring uses dependency injection. We will see what is dependency injection later in this video. So because it uses dependency injection, the applications that we create using Spring are very loosely coupled, or we can say it is very modular. Then Spring uses declarative programming, which is also called as aspect-oriented programming, which is used for cross-cutting concerns. By cross-cutting concerns, we mean there are many concerns of an application which the client may not verbally say. For example, if the client is asking us to write a web application for railway ticket booking system, then the client will not specify explicitly that the application needs to be secure, or there needs to be proper transaction management, there needs to be proper commit rollback in case the transaction fails, and so on. So the client won't verbally say that uh, the client needs security and transaction management in his system, but these are cross-cutting concerns. So along with developing the application for the client, we will also have to take care of security and transaction management as a developer. But many of the times, these cross-cutting concerns like logging or security or transaction management, all these functionality are very redundant code. So that is why Spring allows us to reduce this boilerplate code. Spring also provides an integration layer so that we can easily integrate with other platforms, other Java platform frameworks or libraries like JUnit, which is used for unit testing, or Log4j, which is used for logging. Using Spring, we can also connect to a database or query the database or manage the data from the database very easily if we are using a Spring database access object. So we can, a developer may not know JDBC and then too can very easily access a database using Spring DAO. Also, using Spring, we can write web applications because there is a web framework, Spring MVC, which allows us to write web applications. There are many other types of projects that we can create. For example, we can create Spring projects for Android, Spring projects for the cloud. We can create many web services, or we can create many REST services, and so on. So to know the details of what all Spring projects are provided, you can check the website of Spring, that is spring.io. Spring uses inversion of control. which is an object oriented programming practice where the object binding is done at runtime instead of compile time. So, at compile time, the type of the object may not be known using static analysis. This is based on the concept of dynamic or runtime polymorphism, which is also called as late binding or dynamic binding. It removes the dependency from our code, which makes the code very easy to manage. And because the code is very modular, testing the application becomes very easy. So, in any application that we use, in any object oriented application, there are many objects which interact with one another. So, let's say we have these two objects in our application, but these two objects depend on some other objects. So, let's say these have references of some other object, and these in turn may be dependent on some other object. So, what happens in this case is that our code becomes very tightly coupled since the object creation takes up most of our application code. So, what Spring does is Spring container, which is also called the IOC container, which is inversion of control container, it uses dependency injection to instantiate the objects by reading the file which is called Spring configuration file. So this Spring configuration file is an XML file, and all the details of how to create the object and what data is contained in the object is written inside the Spring configuration file. And using this file, the IOC container will instantiate objects. That is, we do not need to create or instantiate the objects in our Java code. They will be created by the IOC container or the Spring container. Then the inversion of control container is also responsible for wiring the objects together. That is, if there are references of one object in another object, or if there is a collection which is contained inside some other object, then the wiring of these objects together or the configuration of these objects, all of it will be done by the inversion of control container by reading the Spring configuration file. So the programmer need not worry about creation of the objects or creation of the collections and then which reference to set where. Also, because the objects are modular, they are written inside the Spring configuration. We can modify the Spring configuration file if we want any changes in our objects or the dependencies. Also, the IOC container will be responsible for managing the entire life cycle of the object. So, right from the initialization till the destruction, Spring will be responsible to manage the life cycle of the object. The developer need not worry about this. The developer can only focus on implementing the logic for the application. The IOC container also takes care of many non-functional requirements like handling large number of sessions at a time. So the programmer need not worry about all such non-functional requirements, and everything will be done by the IOC container.